So in this lesson, we're going to look at our first full-on business application lesson. We kind of needed to get some things like limits and derivatives kind of out of the way, or at least introduce them first. So today's lesson, we're going to kind of relate the concept of derivatives to the field of economics. Okay, but before we do that, let's review a few things from the class before this one. So when we have a business, small business or otherwise, we almost always would want to know what our cost associated with that business is. So we call the cost function capital C of X, okay? But it is the total cost in producing X units. Okay, so an example of that notation-wise is if you're finding C of 200, that is just going to be the total cost of the first 200 units. Okay, we also discussed the revenue function in the class before this one. So we use capital R of X to talk about revenue. Make sure you know the difference between revenue and profit. Those aren't the same thing, but I usually have students think they're the same. Revenue is strictly money brought in from the sale of X units. It does not take into account how much it cost you to sell those units or to make those units or anything like that. Profit is the bottom line function. Okay, so when we discuss the profit function, we normally use capital P of X. And capital P of X, if you want the profit of any business, you would take the money you brought in and you would subtract off the cost it took you to sell those items or make those items. So this is actually more useful for business owners to know. It's the money that a company actually gets to keep from selling X units once all the bills are paid, or once the costs are paid. So you'll actually hear in like news reports and business reports, sometimes they'll say like this is a multi-million-dollar company, but often they're talking about the revenue of that company. And frankly, it doesn't do you much good to make $1 million in your business if you spend that or more. Okay, so always make sure that you're referring to revenue and cost when you mean to. Okay, so really what you want most of the time to know is the profit, not the revenue. All right, so something new for this class, though, that you wouldn't have covered last semester is something called marginal cost. Okay, the marginal cost is the cost in producing an additional item. Or an additional unit, given that a certain number of units have already been produced. So often you look at this like, I've already spent the money on the first, say, 2,000 items. I want to know what it would cost me to make the next item, that 2,001st item. So I like to say it like this. It's the cost of one more unit at whatever production level you happen to be at. Okay, so marginal means one more. And so the marginal cost function is equal to the derivative. That's where derivatives come into play in this section. And it's equal to the derivative of the cost function because it represents a rate of change. Remember what derivative is, right? It's the slope of the tangent. So it would be the rate of change for any production value or any unit number. So the derivative describes the rate of change at any point. And so because it's equal to the derivative, we are going to use derivative notation for that. So the marginal cost will be noted by C prime of x. All right, so let's look at a problem that uses marginal cost. So let's say that a company makes CDs at a cost of C of x equals 2,000 plus 2x plus 0.0001 x squared, where x equals the number of CDs. And what I want you to do is I want you to compare the exact cost to the marginal cost. And let's say I ask you to find the exact cost of the 1,001st CD and compare that to the marginal cost at that level. So we're going to compare exact cost to marginal cost. In other words, compare means we need to find them both and talk about if they're close, how do they relate to each other, and all that good stuff. So let's just split this into two parts. So let's look at the exact cost. Now for the exact cost, you don't need calculus. Okay? You don't need derivatives to find the exact cost. The exact cost, first we would start with C of 1,001. Okay, let's talk about what that means though. C of 1,001 means the cost of all the first 1,001 CDs. Okay, notice I don't want all the first, I don't want items 1 through 1,001. I only want the 1,001st one. So notice if I subtracted off C of 1,000, then it would take away the first 1,000 that I don't really care about, right? Because this would be the cost of all the first 1,000 CDs. And the only one that would remain after I subtracted would be the 1,001st exactly. All right, so to find C of 1,001, I would do 2,000 plus 2 times 1,001 plus 0.0001 times 1,001 squared. And to find C of 1,000, I would do the same, but plug in 1,000 to the original function, to that cost function. All right, so in the end, I'm not going to show you that on the calculator. I feel confident you can enter that in. If you enter in 2001 into the original cost function, you get $3,901.80. By the way, you should know that's not your final answer because that's not a reasonable cost for a CD, okay, unless it's plated in diamonds, right? So that's too much, right? The reason that's so high is because it's the cost of all the first 1,001 CDs. And then if you plug 2,000 in, you get 3,900. So notice the difference is just $1.80. Okay, this is the actual cost of the 1,001st CD. Okay, just using algebra, just using function values, that was the exact cost. So now let's look at the marginal cost. Now marginal means derivative. Anytime you see marginal cost or marginal anything really, the word marginal should make you think to yourself, hey, I need to find the derivative. Okay, luckily we have a shortcut from the last lesson on how to find the derivative. So if you look at your C of x equation, Okay, the C of x, it's not on screen anymore, but it was 2,000 plus 2x plus 0.0001 x squared. And if you take the derivative of that, so let's write the original function just because I want to make sure that we can see it. So here's the original, right? So let's find the derivative. Now remember, the derivative of any constant, even one as high as 2,000, is 0. Okay, the derivative of 2x, so remember if we have a 1 exponent, right? So remember, this is where you bring the power around to the front and reduce the power by 1. Bring this power around to the front and reduce the power by 1. So we're going to get just 2, because 1 times 2 is 2, and then if we reduce the power of x by 1, we get no more x's. Here we're going to get 0.0002 and then x to the first power. So here's our equation we're going to use. But remember what marginal cost is. Marginal cost is the cost of the next CD. It's always the cost of the next item. So just a little tricky when you're dealing with marginal is we're not going to plug in 1001. We're actually just going to plug in 1,000, because this would mean the next CD, which would be the 1,001st. Okay, so notice we get 2 plus 0.0002 and then times 1,000. Okay, notice we get $1.80 here. Okay, and again, this describes the cost of the 1,001st CD. So to be honest, these values, notice part A and B are exactly the same as each other. Okay, they won't always be the same, but they will always be really, really close to each other. So the marginal cost is going to be equivalent to the exact cost. That squiggly equal sign means approximately. And by the way, notice if you know how to find derivative, this is actually a much quicker version than having to plug in 2 values into that big old long equation that we started with. Okay, so once you know how to find derivative, it is quicker and easier to find the cost of the next item using derivative rather than going through the original function. But don't be surprised on your homework if these are a little bit off from each other. So this is the actual cost, and sometimes this might be off by a penny or 2, or maybe even 10 cents, depending on the price of the item. So remember, this is just an approximation of this. Okay, so part A is the exact answer, part B is an approximation. Just in this example, it was a really good approximation. All right, so something else we talk about when we discuss cost is the average cost. Okay, so we've talked about total cost, we've talked about marginal cost. The average cost is just what it sounds like. It's the average cost per unit for producing X units. So rather than just tell you what this equation is, I want you to think about how you would figure this out. Okay, so let me give you like a brief example. Let's say that we have a business and it costs $100,000 to produce 1,000 units of our product. Doesn't even matter what our product is. Okay, so it costs a total of $100,000 and that gives us 1,000 units. Okay. Then how would we find the average cost per unit? So think about that. Pause the video if you need to. Okay, the average cost per unit would be for you to take that $100,000 amount, right, and just divide it by how many units there were. Okay, so in the end, we end up getting $100 per unit for this example. So if you take 100 times 1,000, you'll have a total cost of 100,000. Okay, so the average cost formula always involves these two quantities. Okay, first of all, the notation for average cost is a C with a bar over it. You literally say this C bar of X, so you call it C bar. And the formula is always total cost divided by X. So I'm going to circle this. This is the formula for average cost. I will want you to know it, but if you'll think of it in terms of a dollar amount, you can usually figure out what it is. So divide the total costs that you have divided by however many units you had. Okay, so let's look at another application problem. So let's say that the cost of printing X dictionaries for some company is C of X equal to 20,000 plus 10X. And so then I'm going to ask you to find some things based on this. So the first thing I want you to do is find the average cost equation. And I want you to find the average cost per unit if we make 1,000 dictionaries. So remember our notation for average cost. Average cost, we represent that with C bar of X, not just C. And the formula for that is the total cost function divided by however many items we have. So it's basically the 20,000 plus 10X and then over X. So we take the cost equation we were given and put it over X. But another way we can write this, and this will be useful to us later, is we can actually, when we have a single term in the denominator, we can pull it apart into two fractions. So this is the same as saying 20,000 divided by X plus 10. Okay? In other words, 20,000 over X plus 10X over X, but then the X's go away. So that's the average cost function. Now let's find the average cost if 1,000 items are produced. So notice I don't say C of X, I say C bar of 1,000 rather than just C of 1,000. So I'm going to take 20,000 divided by 1,000 plus 10. So 20,000 divided by 1,000 is 20, plus 10 would be 30. And make sure you know what this means. This means the average cost per dictionary is $30. Okay, so for every dictionary we produce at this level, then we're having a cost of $30, an additional cost of $30. All right, so what if I said to find the marginal cost? So the marginal cost for a production level of 1,000. Okay, so remind yourself what the word marginal means. Okay, so remember I told you anytime you see the word marginal, you should think to yourself that means derivative. Okay, so we have our C of X right here. So what would the derivative of this be? So let's write this down. C prime of X equals, now the derivative of 20,000 is just 0. The derivative of 10x, if you picture it as 10 to the x to the first power and you move that power around to the front, the derivative is just going to be 10. Okay, so that's my answer, and let's make sure we can describe what that means. So the cost per dictionary if the previous dictionaries were ignored. Or I'm just going to say if the previous dictionaries have already been produced. So So in other words, we're ignoring the cost of the first 1,000 dictionaries. This is going to be the cost of the next one. Okay, so if we already paid for the first 1,000 dictionaries, if we want to make one more, let's say, at this level, it would cost us $10. Notice we did not get the same thing for marginal cost and average cost. They are two completely different things. Average cost has the total cost divided by the number of units. Okay? Marginal cost is just the cost of that very next dictionary. So we can also find marginal average cost. Okay, remember, marginal means derivative, so what that would look like is the derivative of c bar of x, or c bar prime of x, if you will. Don't let that notation throw you off. It's just the derivative of this c bar function. All right, so what if I told you to find that equation for the above example? So let's remind ourselves what plain old c bar of x was. Remember, we got 20,000 over x plus 10. But we're not going to be able to find the derivative of this written in this way. So we practiced some kind of like this before in the section before this. But we're going to rewrite this as 20,000 x to the negative 1 power plus 10. Okay. Notice, this is still c bar of x. Okay, I haven't done the derivative yet. I haven't moved the power out to the front and done that derivative trick yet. So now, if I want c bar prime of x, I'm just going to take this exponential form and now do the derivative trick with it, right? So move the negative 1 around to the front, and you'll get negative 20,000 x to the, be careful, what's negative 1? Take away 1, right? Negative 1 minus 1 is actually negative 2 plus 10. Oh, and I made a mistake, right? The derivative of 10 is actually not 10, it's actually 0. So don't do what I just did there and make a little mistake like that. So in the end, I would want you to write this as negative 20,000 over x squared. Okay, so we've talked a lot about cost. So what do you guess marginal revenue is if we remember that marginal means derivative? Okay, so marginal revenue will be the derivative of the revenue function. Okay, so it will be instead of the cost of the next item, it will be the revenue brought in from the sale of the next item. Marginal profit, we will denote that as p prime of x, will be the profit brought in by the sale of the next item. Let's say the profit earned rather than brought in. So remember how we have a relationship between revenue and cost and profit? The same is true of the marginal values. So if we want the marginal revenue, or profit rather, we can just take the marginal revenue minus the marginal cost. All right, so let's look at a couple application problems here. So a company makes drill bits. And let's say that the daily cost function is C of x equals 1,000 plus 25x minus 0.1x squared, where x is the number of drill bits. So I'm just going to ask you for some different quantities or some different equations. So the first thing is, what if I ask you for C bar of x? Okay, you have to remember what that means, right? C bar of x means the average cost function. So I'm going to take 1,000 plus 25x minus 0.1x squared, and I'm going to divide that by x. Okay. Now, I could leave the function in this form, okay, if I want to. So for this one, I think I'll just go ahead and leave that as the average cost. I'm not going to change forms, but you'll find out maybe in part B that I might need to change forms at that point. So what if I asked you to find the derivative of that? Okay. Well, notice the derivative of that, I'm not going to be able to do that in this form right here. First, I'm going to have to find, okay, so first, before you can ever find the derivative, we're going to need to change this so that it's an exponential form. In other words, this over x, and then this over x. So notice we're going to get, we'll rewrite that, 1,000 over x plus 25x over x minus 0.1x squared over x. So if you simplify a whole bunch of stuff, you're going to get 1,000 x to the negative 1 plus 25, right? Because here the x's would go away. Okay, algebraically here, this x will go away, leaving 1 on top. So I'm going to get minus 0.1x. So this isn't my answer, remember. This is just my cost function rewritten. So now let's find the derivative of that cost function using our power rule, right? So you always ask yourself, have I done the derivative yet? And how you can always answer that is, did I do the power moving around to the front thing? Okay, and if the answer is no, then you didn't do the derivative yet. So if you move this around to the front, you're going to get negative 1,000 x to the negative 2, right? Because we move the power out to the front, reduce the power by 1. The derivative of 25, that's just a constant, so that's 0. The derivative of this would just be minus 0.1, because if you move the power out to the front, you'll get, and reduce the power by 1, you'll have no more x's. So rewritten, it's negative 1,000 over x squared, because remember we don't leave negative exponents, minus 0.1. Okay, so this is the average cost function. This is the derivative of that. Okay, so now let's say that I told you to find C bar of 10 and C bar prime of 10 and briefly explain. So I'll probably do this on your first test too. If I ask you to briefly explain, I'm just asking you to tell me what it means. Don't just give me the number answer, describe for me what it means. Okay. So first let's start with C bar of 10. So go back up to part A and we're just going to plug in 10. So 1,000 plus 25 times 10 minus 0.1 times 10 squared all over 10. Okay. Use your calculator. So you'll end up getting $124. Okay. And that's per drill bit because remember we're talking about average cost. So I'm going to put this in parentheses. This is the average cost per bit. This is the cost that is incurred by the company to make each drill bit at that level. So if I'm asked to find C bar prime of 10, that is asking for the derivative. So I need to go back to part B for that and plug in 10. So I get negative 1,000 over 10 squared minus 0.1. So again, use your calculator. But notice we get a negative amount, so it's negative $10.10. Okay? Don't be alarmed if you get a negative value, okay? That just means that the average cost, remember this is a rate of change since it's a derivative, the average cost per bit is decreasing. So it doesn't mean that we're getting negative dollars. It means the cost is going down by $10.10 per drill bit at this level. So think of it like this. Most of the time in business, the more items you make, the less they each will cost, right? So as you produce more and more and more, each one's going to cost you less and less. Okay, so when I say briefly explain, this is what I'm looking for. Just a quick little snippet of what you think the answer means. All right, so lastly for this one, what if I ask you to use the previous result to predict the average cost per bit of 11 drill bits per day? So I just found some information about 10 drill bits per day. So what would you expect, or what would you predict would happen if we make an 11th one? Okay, so let's talk about that. So the average cost for 10 is 124. But at this level, our average cost is reducing by $10.10 for the next one we make. Notice the 11th drill bit is the next one. So if we just subtract off $10.10, then we'll get $113.90. So if we make just one more drill bit, our average cost per drill bit is less, okay? And then as we make one more, it'll be even less, okay? But it'll always be going down by kind of a different amount. Okay, so for now, we're just going to leave it at that. All right, so I've been focusing a lot on cost. So I want to make sure that I at least mention that you might not have marginal cost. You might have something else, like marginal revenue or marginal profit. So if the profit function is x squared minus 4x plus 1,000, and I tell you to find the marginal profit, again, anytime you see that word marginal, just think to yourself you need to do derivative. So this would be p prime of x, and then just do your power rule, right? The 2 comes around to the front, so 2x minus 4. Okay, so that would be all there is to that. So something we cover in business math, again, I kind of, if you can't tell, I'm kind of a review as I go kind of teacher. So let's talk a little bit more about revenue when you don't know it. So revenue is R of X. Remember, revenue is how much money is brought in from the sale of X units. Okay, so think about that logically. You actually only need to know 2 things when you want to know the revenue. The revenue is usually an easier function than some of the others. Okay, not always, but most of the time. In other words, if you know the price and you know how many items you sell, then that will always equal the revenue. Okay, so this is little p. Don't confuse that with capital P. Capital P is usually profit. Little p is usually price. And X, remember, is just the number of units. So if you aren't given the revenue equation, but you are given the price, then you should be able to find the revenue equation using this easy formula, P times X. So let's do one more. So if the price is little p equals negative 0.02x plus 400 let's say that I told you to find the marginal revenue. And use that to find the revenue from the sale of the 101st unit. So first things first, when you see marginal, that should tell you, hey, I'm going to need to find derivative. Notice this time, though, I don't have an R of X equation yet. Okay, so the first thing I'm going to need to do is find out what R of X is. Okay, and I'm going to do that by using the above equation. R of X is equal to price times quantity. So my price equation is negative 0.02x plus 400, and my quantity is X. So this is just like a backwards distributive property kind of. I know we're used to seeing maybe the number in the front, but in the end we'll get R of X equals negative 0.02x squared plus 400x. So I'm going to circle this, but this isn't really my final answer, but I'm going to use it. I had to have R of X before I could ever have the derivative function. So now let's answer the question that was actually asked of us, find the derivative. So again, we're doing power rule, right? Move that 2 around to the front and we'll get negative 0.04x plus 400, okay? Because the derivative of 400x, if you move the 1 out to the front, you'll get 400. So remember, reduce the power by 1, move the power out to the front. Okay, so I'm going to box this in. So that's one of the things I was asked to find, the marginal revenue. Okay, but now I need the 101st unit. So let's underline that, 101st unit. So remember, revenue, or marginal rather, means the next item. So I actually, just like before with cost, I don't actually want R prime of 101. I actually want R prime of 100. Remember why we said that? Because this means the revenue of the next item. And the next one would be the 101st one. So we'll plug it in, negative 0.04 times 100 plus 400. So if you use your calculator and figure all of that out, you're going to get 396. Okay, so let's briefly describe what this means. This means that selling the 101st unit or item brings in $396 more. That's what it means. Okay, now remember, that doesn't mean the company gets to keep that. It just means that that's the revenue that's brought in. So to be able to do this lesson, you certainly have to have a pretty strong ability to be able to use those formulas from the last lecture and do derivatives. So my strong suggestion, if you're struggling with this section, is make sure you have the section down before it, the 10.5. Make sure you're really good at finding the derivatives using that power rule, and then maybe come back and try to do this section if you're struggling.